Hi, welcome to Atomic Structure 2, Introducing Lewis dot diagrams. My name is Dr. English, and in this tutorial today, we are going to be looking at how to construct Lewis dot diagrams, using the periodic table to determine valence electrons, assigning the dots to groups 1, 2, 13 through 18, and then finally, at the end, a little bit of practice. So, how to write a Lewis dot structure. The first thing I want you to do is to imagine a box around the element symbol. So this X right here is representing all elements on the periodic table. We're using this as a very generic symbol to represent any element in a particular group, and it will help us with a general format. So we're going to imagine a box around this. So a little box just like this. When we write Lewis dot diagrams, we always want to use the specific element symbol written appropriately and the appropriate number of dots. Big thing that you need to remember is that there can only be 2 electrons on each side of the symbol of elements for a maximum of 8 electrons total. Now let's look at your periodic table. Your periodic table gives you all sorts of different types of electron configurations. So an example of an electron configuration and using that to identify valence electrons, we could look at strontium, and strontium is right here. So if we zoom in on this, we'll see that the electron configuration for strontium is 2, 8, 18, 8, 2. And again, like we've talked about in previous tutorials, that last number will be the number of valence electrons. And what we'll notice here is that all the elements in this particular group end with the number 2. And one thing to notice is that they are in group 2. Another example that we can look at is the element bromine. Bromine has an electron configuration of 2, 8, 18, 7, and bromine is located right here on the periodic table. So the number of valence electrons in bromine is 7, and we notice that it is in group 17, and all elements in this group will end with the number 7. Let's talk about group 1. So for a group 1 element, which is going to have 1 valence electron, we're going to put 1 electron on one side of the box. So here's our generic format right here. So in comes our dot. We're going to put the dot at the top. Let's look at a couple of examples. Cesium. Cesium has an electron configuration of 2, 8, 18, 8, 1. It has 1 valence electron. Therefore, around cesium, maybe we'll put it on that side. Lithium, 2, 1, 1 valence electron. So maybe this time we'll put it on the opposite side. And for sodium, it's 2, 8, 1. Maybe this time we'll put it on the bottom. It really doesn't matter where you put the dot to start with. Just that, again, you can only have a maximum of 2 electrons per side. Now let's look at group 2. Group 2 elements will have 2 valence electrons. So for the second electron, place it on the same side as the first. Now, a little disclaimer. This is how I teach Lewis dot diagrams. If your teacher has a different way of doing it, of course you should do the way that they do it. With this generic X right here, with 2 electrons, I'm going to put 1 on here and 1 on the opposite side. So it'll be 2 electrons together on one side. Let's look at magnesium. Magnesium has an electron configuration of 2, 8, 2. So 2 electrons at the end. Therefore, 2 electrons, let's say it's over on the right-hand side. Calcium, 2, 8, 8, 2. The electrons on the bottom. Strontium, 2, 8, 18, 8, 2. We can put the 2 electrons around the left-hand side. It doesn't matter what side the electrons occupy. I'm just a big believer in keeping them together. Now let's look at group 13 with 3 valence electrons. For the third electron, place the electron on a side adjacent to the first filled side. So let's look at our generic X right here. So I'm going to have 1, 2, 3. So here's my first 2 together. Here's the third adjacent. Let's look at aluminum. Aluminum has an electron configuration of 2, 8, 3. So this time, 1, 2, 3. Gallium, 2, 8, 18, 3. So there's again is our 3 valence electrons at the end. So this time, 1, 2, 3. We have our pair of electrons at the bottom and 1 adjacent. Then indium, 2, 8, 18, 18, 3. 3 valence electrons in the end. So when the dots are added, 1, 2, 3. 3 dots coming in. 1 filled side, 1 by itself. They're adjacent to each other. All of these elements are in the same group, and that's an important thing to remember. Group 14. Now group 14 with 4 valence electrons is going to sort of go against what we've been doing so far with putting our first 2 valence electrons together. For the 4th electron, place 1 electron on each side of the symbol. Now, you might be like, well, why are we doing that? And if you go on to an honors chem class or an AP chemistry class, you learn about something known as hybridization, and all of a sudden it makes a lot of sense. But for right now, we're just going to buy into the fact that there's going to be 1 electron in each side, and that's going to be really important when we get to chemical bonding. So 1, 2, 3, 4. Carbon has an electron configuration of 2, 4 valence electrons. So around carbon, 1, 2, 3, 4. Silicon has an electron configuration of 2, 8, 4. Again, 4 at the end. 1, 2, 3, 4. And germanium has an electron configuration of 2, 8, 18, 4. 4 valence electrons at the end. 1, 2, 3, 4. Group 15. Group 15 is going to have 5 valence electrons. For 5 valence electrons, place the first 2 electrons on the same side, then distribute the next 3, 1 to each of the remaining sides of the symbol. So with X, I'm going to have 1, 2, 3, 4, 5. So 1 filled side and the other 3 distributed, 1 to each side of the symbol. For nitrogen, nitrogen has an electron configuration of 2, 5. So 5 valence electrons. So 1, 2, 3, 4, 5. Phosphorus. Phosphorus has an electron configuration of 2, 8, 5. 5 valence electrons at the end. 1, 2, 3, 4, 5. Again, it does not matter which side you have your 2 electrons, but you need to keep that side filled, and then 1 on each side after that. And again, the important thing to realize is that there is a method to the madness, and this will come in very handy when we start chemical bonding. Group 16, 6 valence electrons. For 6 electrons, follow the rules for 5 electrons, but the 6th electron must be placed adjacent to the first filled side, and I am adamant about this with my students. Other people might be like, it really doesn't matter, but for me, especially when we get into the bonding of a water molecule and the shape of a water molecule and ultimately why it's going to be polar, which you're going to learn about later, water's got to be bent. It's got to be a polar molecule. Therefore, for anything in group 16, you're going to follow the following format. 1, 2, 3, 4, 5. There's my first filled side. 6. There's my second filled side, and again, you will notice that they are adjacent to each other. Let's look at oxygen. Oxygen is 2, 6 valence electrons, so 1, 2, 3, 4, 5, 6. Selenium, 2, 8, 18, 6 valence electrons, so 1, 2, 3, 4, 5, 6. Group 17, 7 valence electrons. For 7 valence electrons, distribute 2 electrons to each side and the 7th by itself. So if we distribute those electrons around the X, 1, 2, 3, 4, 5, 6, 7, 3 filled sides, 1 electron by itself. For fluorine, fluorine has an electron configuration of 2, 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Chlorine has an electron configuration of 2, 8, 7, so 7 valence electrons in the end. 1, 2, 3, 4, 5, 6, 7. We notice that everything in group 17 will have 7 valence electrons. These are how the electrons are going to be filled. Group 18, 8 valence electrons. This is great because the maximum number of dots that you can put around one of these symbols is 8. So each side is just going to have 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. 2 electrons per side. Let's look at neon. Oh, 2, 8 valence electrons, 8 valence electrons. Argon, 2, 8, 8 valence electrons in the end, 8 valence electrons. The only element in group 18 that does not follow this rule is helium. Helium has an electron configuration of 2. Therefore, you can only have 2 electrons max in that first shell. So helium only has 2 electrons and not 8. Now I'd like you to stop and do a little bit of practice. So for each of the following elements, construct a Lewis dot diagram. Let's see what you can do. Welcome back. Right now what we're going to do is we're going to construct Lewis dot diagrams for each one of these elements. So let's start with nitrogen. Nitrogen is in group 15. Therefore, it's going to have 5 valence electrons. So 1, 2, 3, 4, 5. For lead is in group 14, so 1 on each side. 1, 2, 3, 4. For strontium's in group 2. I'm going to put 2 valence electrons next to each other. 1, 2. Iodine is in group 17, so it's going to have 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Cesium is in group 1, so that's just going to have 1 right there. And finally, boron is in group 13, so 1, 2, 3. So what did we learn from this tutorial? We talked about how to construct Lewis dot diagrams. We used our periodic table to determine valence electrons. We assigned dots to groups 1 and 2, 13 through 18, and then finally at the end we did a little bit of practice. Need more help? Feel free to contact me. Have a great day.